Welcome to the 12th part of VCAA Specialist Math 2022 exam papers. In this video, we will solve exam paper 2, section B, question 5, which consists of 5 parts. The problem in part A was that many students did not notice the acceleration was 0. Section 1 of part B was generally well done. The most common error was showing resistance acting up the plane or omitting one of the forces. In section 2 of part B, the common error was not using the normal force. In part C, there are many incorrect solutions, and some students were confused between the initial and final velocities. A common error in part D was to assume that the time for the motion down the plane was the same as for up the plane. Only a minority of students took account of the change of direction of the resistance force. Welcome to this VCAA Specialist Math exam paper series. This is section B of 2022 exam 2 paper. There are total 6 extended response questions in section B. In this video, we will present the 5th extended response question. Question 5, based on the diagram shown below, has two forces of magnitude 10 square root 2n, 20 square root 3n, and a horizontal resistance force of magnitude 5kn, where k is real, acting on an object of mass 5 kg. All forces act in the same vertical plane. The force of magnitude 20 square root 3n acts at an angle of 30 degrees to the horizontal direction, while the force of magnitude 10 square root 2n acts at an angle of 15 degrees to the force of magnitude 20 square root 3n. The object moves to the right on the horizontal surface, and at point O, it has a speed of 0.5 meters per second. There are 5 parts in this question. Part A is to show that the acceleration of the object is given by a minus k meters per second squared. After 5 seconds, the object reaches point P, where it has a speed of 2 meters per second. Part B is to find the change in momentum in kg meters per second of the object from t equals 0 to t equals 5 seconds. Part C is to show that the value of k equals 7.7. Part D is to find the distance in meters from point O to point P. In Part E, when the object passes point P, the forces of magnitude 20 square root 3n and 10 square root 2n cease to act, and the object begins to move up the plane PQ at a reduced speed of 1.95 meters per second. The plane is inclined at an angle of theta degrees to the horizontal. The object is subject to a resistance force of 38.5 N acting parallel to the plane. The object comes to rest 0.2 meters up the plane from P. The question here is to find the angle theta. Now, let's come back to answer part A of this question. According to Newton's second law, sigma F equals ma. The sum of all horizontal forces, 10 square root 2 multiplies cosine of 45 degrees plus 20 square root 3 multiplies cosine of 30 degrees minus 5k equals 5a, which gives the acceleration a equals 10 plus 30 minus 5k, all over 5, which equals 8 minus k. As for part B of this question, the change of momentum delta p after traveling 5 seconds is written to 5 times 2 minus 5 times 0.5, which equals 7.5 kg meter per second. Based on the formula of constant acceleration motion, we have v equals u plus at. After the values of u, v, and t being substituted, it becomes 2 equals 0.5 plus 8 minus k, or in parentheses times 5, which gives k equals 7.7. In part D, according to the motion formula, d equals ut plus at squared over 2, which equals 0.5 times 5 plus 8 minus 7.7, or in parentheses, times 5 squared over 2, which equals 6.25 meters. Alternatively, we may use the formula v squared minus u squared equals 2ad to address this part of the question, in which d equals 2 squared minus 0.5 squared, all over the product of 2 times 8 minus 7.7, or in parentheses, which equals 6.25 meters. As for part E of this question, in order to find the angle theta, we need to establish the motion equation along the inclined plane as shown in the diagram. Since the initial speed u equals 1.95 meters per second, the final speed equals v equals 0. The resistance force R equals 38.5 N, and the traveled distance x equals 0.2 meters. We have the motion formula v squared minus u squared equals 2ax, which gives a equals v squared minus u squared, all over 2x. In addition, we may also apply the Newton's second law along the inclined plane. Negative mg times sine theta minus r equals ma, in which the reference of direction is up the inclined plane. So the acceleration a equals negative g times sine theta minus r over m. Combining these two equations, we have the relation v squared minus u squared, all over 2x, equals negative g times sine theta minus r over m. After rearranging and simplifying the equation, we calculate that the sine theta equals 0.1843, which gives theta approximately equals 10.6 degrees.
If you enjoyed this video, please give it a thumbs up and subscribe to help me make more math content like this. I will see you in the next video.